governed by Cygnus's onboard computers, has been flawless since the new burn plan was devised by the Northrop Grumman engineers over the course of the last 24 hours. All of the burns have been executed on time and to full duration, and Cygnus now is in a hold point some 250 meters directly below the International Space Station. In this view, periodically you may be able to ascertain jet firings on Cygnus as it maintains its hold position until it is commanded to resume its very slow approach up that R bar, the radial vector. Imagine if you're looking at a crosshair view, the station is in the middle of the crosshairs and Cygnus is just south of where the station would be located. Here in the flight control room, the Attitude Determination and Control Officer, the ADCO, reports to Flight Director Garrett Hayne that the International Space Station is in the correct orientation and all of its systems have been configured properly for final approach for capture that is scheduled just under an hour from now.
1.102.
Copies. Per step 2 of 1.102, our prior range is 251.9 and decreasing.
NASA's Zena Cardman responding to spacecraft communicator Aaron Edwards here in Mission Control, as Cardman and Johnny Kim are alongside one another in the cupola at the robotics workstation. Both Cygnus XL and the International Space Station have moved into an orbital sunset over the northwest Pacific Ocean, about to begin a northwest to southeasterly track. We're about 34 minutes away from an orbital sunrise.
Station on 2 per step 2 of 1.102. LEDs on Cygnus command panel match what we are expecting. Prior range 251.2. We are in hold.
We copy that, Zena, and we're ready for your block Bravo when you're ready.
Then we copy, and the gray corridor has showed up. We'll start our block Bravo calls now.
If you're just joining us, you're looking at the view of the Northrop Grumman Cygnus XL cargo craft that is currently
using monitor 3. The light is within the corridor. Vehicle size matches the outline. light is 1/2 vehicle length forward of the circle, and the circle is in the center of the corridor.
Again, this view of the Cygnus XL, 250 meters below the station.
Work. Monitor 1 looks to match. Monitor 3 will zoom in to double check.
Zena Cardman in the cupola relaying what she's seeing on monitors at the robotics workstation. Meanwhile, the engineers for Northrop Grumman in Dulles, Virginia have taken a poll for a go to resume approach to the station from 250 meters.
Houston Station, with this lighting and angle, it's difficult to see the light in Monitor 1, but otherwise all calls match. Monitor 1 and Monitor 3.
We copy a similar report for that monitor. Thank you.
With the Northrop Grumman engineers go for resumption of approach from 250 meters, Flight Director Garrett Hain now will poll his team here in Mission Control to receive similar approval to enable Cygnus to resume its approach. Once again, the capture time is estimated at about 6:18 a.m. Central Time, 7:18 a.m. Eastern Time. Installation coverage will begin about an hour and 40 minutes after that. Just to recap, following two abbreviated engine firings that occurred on Tuesday, Northrop Grumman engineers huddled on a new burn plan, ultimately determining that the vehicle's main engine was in good shape, but that the software limits governing those engine firings were set at a very, very conservative level. So those software limits that triggered a premature shutdown of the engine during two rendezvous burns, those limits were reset, recomputed, and a new burn plan was devised. In the meantime, Cygnus phased behind the station to a parking orbit some 500 kilometers behind the station at a safe distance from the complex to enable that troubleshooting to take place throughout the day on Tuesday. The new burn plan has been executed flawlessly. All of Cygnus's systems now are operating perfectly, and all the burns have been executed on time and to full duration.
ISS are configured for approach inside the keep out sphere. Expect approach to resume shortly and stand by for the Cygnus PCS command checkout.
Copies. Standing by for 1.102, step 3.
That call from Aaron Edwards, the Capcom here in Mission Control, to Zena Cardman aboard the station. Situational awareness that we should be seeing the resumption of the approach of Cygnus up the radial vector toward its capture point momentarily.
And station Cygnus has resumed approach. Go for Cygnus PCS command checkout, hold arm per step 3 in 1.102.
Copies. We are go for 1.102, step 3.
Cygnus has resumed, inching its way up the radial vector. The next milestone will be at a point at which Cygnus will reach 100 meters away. There is no stoppage point then. The next planned hold point would come at 30 meters away from the station.
And station, hold arm is command.
And station, we can copy hold command armed. And station, hold arm is confirmed. Go for Cygnus PCS command checkout. Disarm per step 4 in 1.102.
And copies. Go for 1.102, step 4.
Those procedures being radioed up to Zena Cardman essentially involves the crew's actions, should they be necessary, to trigger an abort retreat by Cygnus in the event of a late-minute malfunction of some system. However, Cygnus's systems are rock solid right now. All of its engine firings are on time and to full duration. Everything is continuing to go very smoothly with Cygnus's approach up the radial vector.
And Houston copies. And station Cygnus PCS command checkout was successful. Begin monitoring approach from 250 meters per step 5 in 1.102.
And copies. Continuing with our monitoring per 1.102, step 5.
Cygnus currently about 205 meters below the station, soon to enter the so-called keep-out sphere. This is the very close vicinity, the neighborhood of the International Space Station.
Crew now has the authority to issue an abort if no comms with Houston and the light is outside the corridor.
Copies. We will continue monitoring per 1.102. Block Bravo call. Using monitor 3, the light is within the corridor. Vehicle size matches the vehicle outline. The light is 1/4 vehicle length forward of the circle. The circle is offset 1 vehicle width starboard from the corridor. We still can't see the lights in monitor 1, but the overlays match between monitor 1 and monitor 3.
Thank you, Zena. That's a nominal report.
Cygnus and the International Space Station flying 260 miles over the Pacific Ocean, crossing the equator, moving from northwest to southeast in its orbit inclined 51.6 degrees to either side of the equator. 180 meters now separating Cygnus from the grapple point, the capture point, if you will, at which time Johnny Kim, assisted by Zena Cardman at the cupola workstation, We'll be reaching out with the Canadarm2 robotic arm to latch on to the grapple fixture with the Canadarm2's end effector. Whereas Roscosmos's Progress and SpaceX's Dragon cargo ships automatically dock to their respective docking ports on the station, Cygnus and the upcoming Japan Aerospace Exploration Agency's HTV X1 cargo craft require a grapple and a robotic maneuver for mechanical installation into the common berthing mechanisms to which they will be attached and bolted into place. Cygnus now 146 meters directly below the station, once again making its way very, very methodically up the radial vector to its next milestone, which will be the 100-meter range. Cygnus's systems are operating as advertised. Everything in good shape on the unpiloted cargo craft from Northrop Grumman. This is the new model Cygnus, the XL, that is about 26 feet long, capable of carrying more than 11,000 pounds of cargo. Planned stay of about 6 months on the Unity module's common berthing mechanism at the station.
In station space to ground 2, no changes to previous block Bravo call.
We copy, thanks.
Everything is quiet here in Mission Control at the Northrop Grumman Mission Control Center in Dulles, Virginia. The engineers are carefully watching their consoles poring over the data coming in from the Cygnus craft, which is operating as advertised. Our estimated capture time is about 41 minutes from now, estimated at 6:18 a.m. Central, 7:18 a.m. Eastern Time. Cygnus was launched atop a SpaceX Falcon 9 rocket on Sunday from Pad 40 at the Cape Canaveral Space Force Station. A little less than 15 minutes after launch, Cygnus separated from the second stage of the Falcon 9 to begin its journey. Journey extended by a day to enable engineers to pore over data associated with the premature shutdown of two of the rendezvous burns that Cygnus had conducted, that all traced to extremely conservative software that oversees the engine firings and any fault detection that might be gleaned from the onboard computers. The software limits were recomputed, as was a new burn plan for Cygnus, and since then, all of the engine firings have been conducted perfectly.
Station space to ground 2. High range is 100 meters. No changes to the previous Black Bravo call other than the light is now converging on the circle. Monitors 1 and 3 still match. We are just beginning possibly to pick up the lights in monitor 1, but still difficult to see.
That's a good report. Thank you.
Capcom Erin Edwards acknowledging that call from Zena Cardman on board the station as she continues her periodic reports on what she and Johnny Kim are seeing in their monitors as Cygnus continues to close in for its capture, now just 94 meters away. We're about 13 minutes away from an orbital sunrise as the station and Cygnus fly in formation 260 miles over the Pacific Ocean. can see station structure now in the field of view as Cygnus closes to within about 80 meters. NASA's Johnny Kim, along with Zena Cardman in the workstation at the robotics workstation in the cupola, where they are monitoring Cygnus's approach. Kim will be operating the Canadarm2 to extend its reach to the capture point and then close in very, very methodically for a grapple on the grapple fixture of Cygnus to complete its journey.
Station, space to ground 2, 75-meter prior range, no changes to previous block Bravo call.
We copy your last call, Zena, and for all crew, to prevent potential eye damage during Cygnus approach due to TRIDAR, cease viewing Cygnus from all windows except the cupola.
Copies.
Essentially, that call from Zena Cardman to Capcom Aaron Edwards, referencing the fact that Cygnus is maintaining a perfect path up the radial vector toward its capture point. Next milestone will be the hold point at 30 meters directly below the station. Cygnus now just 63 meters below the station. Everything proceeding on track, on course. No issues being reported with any of Cygnus's systems. Just to recap, once Cygnus is captured by the Canadarm2 robotic arm, Johnny Kim and Zena Cardman will turn over robotic chores to the robotics officer here in Mission Control, who will begin a very, very slow maneuver to reposition Cygnus so that its common berthing mechanism is aligned with the common berthing mechanism on the Earth-facing port of the Unity module of the International Space Station. Very carefully, very deliberately, the two berthing mechanisms will come into contact with one another to begin the process of mechanically torquing 16 bolts, 4 gangs of 4 bolts apiece, to structurally rigidize Cygnus to the Unity module for its 6-month stay. Flying from northwest to southeast, Cygnus and the International Space Station, 260 statute miles above the Earth. We're about 6 minutes away from an orbital sunrise, so we'll get a much better view of Cygnus in its entirety as it approaches its capture point for Johnny Kim and Zena Cardman to extend the Canadarm2 robotic arm to latch on to Cygnus's grapple fixture.
In station, space to ground 2, prior range 50 meters. Using monitor 3, the light is within the corridor. Vehicle size matches the outline. The light is centered in the circle, and the circle is offset 1/2 vehicle width starboard from the corridor. Monitors 1 and 3 match.
That's a good report. Thank you, Zena.
"47 meters now separating Cygnus from the station, closing at a rate of less than 1/10 of a meter per second. Again, just a few minutes from now, we'll come up on the final hold point that is planned in this approach, the 30-meter hold point, for a final systems check by the engineers at Northrop Grumman's Mission Control Center in Dulles, Virginia. Countdown clocks here in Mission Control ticking backward to the expected capture time some 28 minutes from now. On console at this hour is the lead Cygnus mission flight director, Garrett Hain, joined by spacecraft communicator Aaron Edwards. And again, a brief handover on our constellation of satellites on the tracking and data relay satellite system. We'll get our television view from the station back just a moment or two from now. Once Cygnus is bolted into place on the Unity module of the station, it will mark 3 different cargo crafts that will have delivered supplies to the station recently: the SpaceX Dragon, the Roscosmos Progress 93, and now the Cygnus XL, the SS Willie McCool. This view is what Johnny Kim and Zena Cardman are seeing on their monitors in the cupola.
Station space to ground 2, 35 meters, no changes to previous Block Bravo call.
We copy 35 meters.
The data on these screens enable Kim and Cardman to monitor the distance by Cygnus from the station, its rate of closure, and the alignment of Cygnus up the corridor, basically the radial vector, this R bar that I've been referencing. The radial vector is the imaginary line drawn between the station and the center of the Earth. The Cygnus approach is directly from a point below the station up the radial vector to the capture point, at which Johnny Kim will extend the Canadarm2 to latch on to the grapple fixture on the SS Willie McCool. And as we approach daylight over the Pacific Ocean, a better view of the Cygnus XL. Just about at the 30-meter hold point. And we now, right at sunrise, have reached that 30-meter hold point.
Station, confirm 30-meter hold and set up for capture per step 6 in 1.102.
Copies in work.
In Dulles, Virginia, the Northrop Grumman engineers are conducting a poll to get a go for 30-meter departure.
Station space to ground 2, visiting vehicle mode is hold. Prior range 30.9.
Copy 30.9.
Northrop Grumman's engineers are go for departure. We're standing by for a similar approval from the flight control team here in Houston. An excellent view of the Cygnus XL and its familiar golden fantail-shaped ultraflex solar arrays.
Station space to ground 2, for your awareness, we are in procedure 1.110, starting step 3.
We copy.
That call out by Zena Cardman indicating that she and Johnny Kim are beginning work to configure the Canadarm2 robotic arm to begin its extension to the capture point. The view you're looking at is not the station turning. It is rather the Cronus of flight control position here, repositioning that camera view. You can see at the bottom of your screen the end effector on the Canadarm2 robotic arm. The station in Cygnus approaching the west coast of South America, soon to fly over the Andes Mountains. And just a reminder, once the Canadarm2 reaches out to grapple onto Cygnus's grapple fixture, the actual time that we'll call out for the official confirmation of grapple will come when the snares are closed around the grapple pin. Cygnus and station flying in formation. Cygnus maintains its position right now 30 meters away from the International Space Station, soon to resume its approach for its capture by Johnny Kim and Zena Cardman operating the Canadarm2 robotic arm from the workstation in the cupola. There will be a brief briefing, if you will, to the crew from the Capcom here in Mission Control before we move into the final few feet of the maneuvering of the Canadarm2 for capture. Just a few minutes left right now in this station keeping point, 30 meters below the station. All of Cygnus's systems are operating normally. Cygnus and the station now passing off the east coast of South America. The Cygnus XL making its debut for Northrop Grumman, 26 feet in length, capable of carrying more than 11,000 pounds of cargo, soon to become the second unpiloted cargo ship to arrive at the station in just 4 days.
Station, space to ground 2, crew is ready for Cygnus approach to capture point.
And we copy. And Station Cygnus is ready to proceed to the capture point. Expect approach to resume shortly.
Station copies.
Those words from Capcom Aaron Edwards here in Mission Control up to Zena Cardman in the cupola, notifying the crew that Cygnus, all of its systems in great shape, ready to begin its final approach for capture.
And Zena, just so you're tracking, we notice in monitor 1 there's a bit of an exposure or overexposure. We're going to send a command to clear that up.
Copy and appreciate. Looks much better in monitor 1, thank you.
Great view of the Cygnus XL and the station's Canadarm2 robotic arm poised to begin moving in for a grapple. Capture about 13 minutes from now. The two vehicles flying in formation over the South Atlantic.
Station space to ground 2 for a Block Bravo call.
Send it, Zena.
Using monitor 3, the light is in the corridor. The vehicle size matches the vehicle outline. The light is approximately 1/4 vehicle width aft and starboard of the circle, and the circle is in the center of the corridor. Monitors 1 and 3 match.
We copy. That's a good report, and you've got a same on monitors 1 and 3.
Those reports from Zena Cardman confirming that Cygnus is aligned in the approach corridor, just as expected, some 26 meters separating Cygnus from its capture point.
And Station Cygnus has resumed approach to the capture point. Monitor approach within 30 meters per step 7 and 1.102.
Copies in work.
"24 meters away. Cygnus's systems functioning as advertised. No issues reported. So far, a perfect approach.
Station space to ground 2, Block Bravo, no change on monitor 3. On monitor 1, the circle is centered on the corridor and the light is centered in the circle.
We copy. That's a nominal report.
Just about 21 meters separating Cygnus XL from its capture. The station's robotic arm poised to move in to grapple the grapple fixture on the Northrop Grumman cargo craft that will complete its 4-day journey. Once again, we've hit a handover between satellites on our tracking and data relay satellite system. We'll regain our downlink video from the station here momentarily. Cygnus slowly but surely moving in for its capture, now just 18 meters away.
Station space to ground 2, inside of 20 meters, block Bravo call. On monitor 3, the light is within the corridor. Vehicle size matches the outline. The light is centered in the circle, and the circle is centered in the corridor. Monitors 1 and 3 match.
We copy. Good report.
We're about 7.5 minutes away by the clock to our expected capture time. Some 15 meters now separating Cygnus from the point at which it is expected to be grappled by the Canadarm2 robotic arm under the operation of Johnny Kim and Zena Cardman at the robotic workstation in the cupola. It has been a very, very smooth rendezvous since the recomputed rendezvous burn plan began to be executed last night by the Northrop Grumman engineers in Dulles, Virginia. All of the milestones en route to the station have been met per the revised timeline, setting ourselves up for an expected capture at around 6:18 a.m. Central Time, 7:18 a.m. Eastern Time. The word now from the flight control team is that Cygnus has arrived at its capture point. It is at a range of about 17 meters away from the station. Cygnus now will be configured basically into a quiescent mode so that there are no inadvertent thruster firings during the time frame that Johnny Kim begins to extend the Canadarm2 robotic arm for grapple. Northrop Grumman reporting that all of Cygnus XL's systems are now configured for capture.
Capture point hold for step 8 in 1.102.
Copy is in work.
This is Mission Control Houston. We're expecting a resumption of downlink video from the International Space Station momentarily. The Cygnus XL spacecraft that has performed perfectly since a recomputed burn plan was uplinked to the vehicle yesterday.
Capture conditions are confirmed. The crew is ready for Cygnus capture, and we will pick up in 1.110 step 4. On your go.
Roger, and stand by for capture.
With just 12 meters separating Cygnus from the International Space Station.
And station, you are go for Cygnus capture sequence, step 4 in 1.110, Cygnus capture. Begin monitoring the backaway cue card.
Copies. We are go for the capture sequence, picking up in procedure 1.110, step 4, backaway cue card now applied.
And with that call, Johnny Kim will begin to extend the Canadarm2 robotic arm toward the grapple fixture on Cygnus. This view from the end effector camera on the Canadarm2 robotic arm, looking right at the grapple fixture on the Cygnus XL, flanked on either side of its fuselage by the Ultraflex solar arrays. Cygnus and the station currently crossing the southwest coast of Africa, moving from southwest to northeast. Johnny Kim at the controls operating the Canadarm2 robotic arm. And the report is that Cygnus is rock solid, holding steady, awaiting its capture. We're just a moment or two away from seeing the station's thrusters inhibited to prevent any inadvertent firings during the time frame that the Canadarm2 is moving in for its grapple. Just a couple of additional steps here to make sure that all of the station systems are configured properly before Kim begins to move the Canadarm2 in for its grapple. This is the view from the end effector camera on Canadarm2, looking directly at that grapple fixture. Space station now has been commanded into free drift. All thrusters are disabled.
In station, for your awareness, we are beginning our approach.
We copy.
Canadarm2 now in motion. It's go time for Johnny Kim. Cygnus holding very, very steady. Good motion from the arm reported by the robotics officer here in Mission Control. Just a couple of meters away from grapple. 2 meters. Just 1 meter now. And defector approaching the pin. We have soft capture now awaiting snares. And the snares have closed. Signal arrival, Cygnus now at the International Space Station. Grapple time at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time. The International Space Station was flying over the southeastern Congo, the Democratic Republic of the Congo, at the time of capture. Once again, capture timed at 6:24 a.m. Central, 7:24 a.m. Eastern Time. Cygnus's journey to the station now complete, and soon will be attached mechanically to the Unity module of the International Outpost. So all of the rendezvous maneuvers that were based and executed from a revised burn plan that began to unfold late last night were conducted flawlessly by Cygnus. All of its systems performed perfectly, arriving at the station for a grapple at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time.
Station on 2, Cygnus capture complete. Go for Cygnus post-capture reconfiguration. A big congratulations to the NASA and Cygnus teams for a successful Cygnus launch, rendezvous, and capture. Adapting and overcoming unforeseen challenges is something we do at NASA, and I'm very proud to be a part of this team. I'd like to hand the comm over to my crewmate and friend, Mike Fink, who has something very special to say about NG-23.
Welcome aboard the SS William C. McCool. Willie, yeah, he was my astronaut classmate, class of 96, fellow Sardine. He's a gifted pilot, a devoted crewmate, and a man of deep humility whose life continues to inspire us. To see a ship bearing his name safely arrive at the station is a reminder that his courage and kindness are still circling our beautiful planet Earth. Willie and his STS-107 crewmates gave their lives in the pursuit of science, and the experiments they carried aloft continue to shape research today. So, to the teams at Northrop Grumman and NASA who made this mission possible, Thank you for the care and dedication that keep us supplied and connected with home. Every cargo transfer bag, every experiment, every piece of hardware and spare part inside the Cygnus carries your hard work and our gratitude. Willie's legacy lives on in this moment, in our mission, and in the future that we're building together in low Earth orbit and onto the Moon and Mars.
And thanks for that, folks. And from us, a huge congratulations from the team here in Houston and our partners on what is the 51st catch using the Canadarm2. Capturing the SS McCool, as you said, brings aboard important science and supplies that will allow you to continue our mission of discovery on station. Mike, thanks for your words about your friend and our late NASA colleague, Commander William McCool, the namesake of this incredible vehicle. We all think he would have been really proud of the collaboration and perseverance that made this mission a success. Thank you all.
With Cygnus in the firm handshake of the Canadarm2 robotic arm. Those words first from Johnny Kim of NASA, congratulating the Northrop Grumman NASA team for the flawless rendezvous and capture of Cygnus that occurred at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time, and Mike Fink chiming in with words of tribute to the late NASA astronaut Willie McCool, who lost his life in the Columbia accident on February 1st, 2003. Cygnus bearing McCool's name, soon to be mechanically attached to the Unity module of the International Space Station. With Cygnus having been captured by the Canadarm2 robotic arm just a few minutes ago, it will be about an hour and a half to 2 hours before it is mechanically attached to the Unity module on the Earth-facing side of the U.S. segment of the International Space Station. In the meantime, joining us here on console is Bill Spetch, the International Space Station Program's Operations Integration Manager. Bill, thanks for joining us today. A day late, but not a dollar short. Better late than never. Cygnus safely in the grasp of the Canadarm2. Give us a little insight into what transpired over the last 24 to 36 hours that revised the plan to enable Cygnus to come home safely here.
Yeah, as you guys know, it's a very intricate planning exercise that we have to go through to arrive at space station and rendezvous at a very specific point in space. And so when we had a couple of issues with a couple of burns getting cut short, that caused that trajectory to be off. And so it takes some time to go replan that. And making sure that we could arrive at station safely. So the teams took the requisite time to do that replanning, and we ended up here this morning getting successfully captured.
In the end, the spacecraft, the Cygnus itself, performed as advertised, as it was supposed to in its software protection, if you will. Can you give us a little more information about exactly what happened and how Northrop Grumman's engineers worked in concert with NASA to revise this plan?
Sure. The Cygnus spacecraft has a number of monitors that it watches to make sure that everything is going healthy. In this case, there was one specific parameter that appeared to be just off late in these burns that we had cut off, and so that worked exactly as expected, monitoring a current into the engine. And when it does that, it shuts off the burn. And now we're a little bit short on where we needed to be. And so that causes us to actually race out farther in front of the station as opposed to slowing down and coming up underneath it. So we had to do a bit of a racetrack maneuver to burn, then to get above the station, come around behind it, and come back down below to catch up again.
So with today's arrival of Cygnus and its imminent attachment to the station coming up in the next hour and a half or so, that is the second cargo craft to arrive at the station in just 4 days in the wake of the Progress 93, the Roscosmos cargo ship this past Saturday. Some 8.5 tons of cargo arriving at the station in rapid-fire succession. How important was this series of delivery runs?
Oh, it's critically important. You know, we've gone a little bit in terms of time in between major resupplies. Although SpaceX 33 just arrived as well, so this fall we always knew was very, very busy in terms of the amount of cargo. This brings up a lot of critical consumables for the crew, food, water, a lot of extra spares, and of course the great science that we get to do on board the station. So these regular resupply runs and especially this great capability that Cygnus brings and the amount of cargo that it brings to us is critical for us to keep us running smooth and doing the things that we need to do on board to do the research.
You mentioned a busy fall, but it doesn't stop. We're just about 4.5 weeks away from the next cargo ship launch, the debut of the Japan Aerospace Exploration Agency's HTV X1. I know the reviews are beginning in earnest for that launch from the Tanegashima Space Center in southern Japan. What will HTV X1 bring to the table in terms of more cargo and more capability for these delivery activities for the station?
Yeah, it really brings an excellent capability to provide both internal cargo as well as external cargo from just a completely different source. And what we like to do is have as many different sources of resupply as we can. Obviously, if something goes wrong, God forbid that we run into an issue with one aspect of our fleet, having multiple resupply capabilities really is what makes this partnership so strong.
Okay, Bill, very good. Cygnus now in the grasp of the Canadarm2, soon to be mechanically attached to the station, and then the crew can work its way towards opening the hatch probably later today to begin unloading its cargo. We appreciate your time this morning, as always. Bill Spetch, the Operations Integration Manager for the International Space Station Program. Thanks much.
Thanks for having me. Appreciate it.
This is Mission Control Houston, a good view of the SS Willie McCool, the Northrop Grumman Cygnus XL cargo craft that arrived at the space station after a flawless rendezvous this morning with its grapple by the Canadarm2 robotic arm having been executed at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time, as the two vehicles flew 260 miles over Central Africa. The robotics officer here in Mission Control will soon begin to maneuver Cygnus to its installation position on the Earth-facing side of the U.S. segment of the station, ultimately positioning it for alignment for a mechanical capture to the common berthing mechanism on the Unity module of the International Outpost. We will take a break in our coverage now and return at 8 a.m. Central Time, 9 a.m. Eastern Time for installation coverage to latch up the newly arrived Cygnus XL spacecraft to the International Space Station. In the meantime, this is Mission Control Houston.
SpaceX. Go for launch.
Max Q. Stage separation confirmed.
Landing burn.
Successful spacecraft separation.
Cygnus capture complete.
Welcome to ISS, Cygnus.
You heard in that introduction, welcome to ISS, Cygnus, and that is the theme for today. This is Mission Control in Houston, and good morning from the International Space Station Flight Control Room here at the Johnson Space Center. At this hour, Cygnus, attached to the end of the Canadarm2 robotic arm, where it was captured 1 hour and 43 minutes ago by astronauts Johnny Kim and Zena Cardman, operating the arm from the robotic workstation in the cupola of the International Space Station. Currently, these vehicles are flying 260 miles over Western Africa, moving from southwest to northeast in an orbit inclined 51.6 degrees to either side of the equator. Welcome to our installation coverage, which follows in the wake of a flawless rendezvous by the Northrop Grumman Cygnus XL cargo craft. The craft arriving at the station 1 day behind schedule, but after a flawless rendezvous that was executed following a revised burn plan and some adjustments to the onboard software aboard the Cygnus itself, which triggered an abbreviated shutdown of some of the rendezvous burns that had occurred on Tuesday, forcing a 24-hour delay in its arrival at the station. But good things come to those who wait. And there you see Cygnus loaded with some 5.4 tons of cargo for the Expedition 73 crew aboard the International Space Station as it is slowly being maneuvered into its installation position on the Earth-facing port of the Unity module of the International Space Station by the robotics officers here in Mission Control. As mentioned, about an hour and 44 minutes ago, Cygnus completed its slow, methodical rendezvous to the station, pulling up to a capture point, allowing Kim and Cardman to move in with the Canadarm2 robotic arm. This view from the end effector at the end of the Canadarm2 robotic arm as it latched on to the grapple fixture on the Cygnus. A couple of minutes later, the snares closed. The capture occurring at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time, as the two vehicles flew over Central Africa. The installation process, as it begins to unfold over the course of the next hour or so, will call for the vehicle to be maneuvered to an installation point, so its common berthing mechanism, called the passive common berthing mechanism, is aligned with the active common berthing mechanism, which is on the Unity port, the Earth-facing port on the Unity module. Once the two vehicles are perfectly aligned, then the robotics officer will move Cygnus into what is called a capture envelope, allowing 16 bolts, 4 gangs of 4 bolts apiece, to engage and mechanically torque themselves, basically screw themselves into place to form a hard mate for Cygnus onto the International Space Station, where it will spend the next 6 months. The timeline calls for the crew on board the International Space Station to conduct leak checks at the berthing interface between Cygnus and Unity before their scheduled work to open the hatch to Cygnus before they go to bed later today and begin to remove some of the cargo that Cygnus is carrying on board. Today's arrival marks the second cargo ship to reach the International Space Station in the past 4 days. Cygnus arriving at the station just 4 days after the automated docking of the Roscosmos Progress 93 cargo ship that delivered 2.8 tons of cargo, food, fuel, and supplies for the crew on board the complex. Aboard the station in the home stretch of their workday, the Expedition 73 crew seen in this crew portrait, Oleg Platonov of Roscosmos on the far left in the back row, Johnny Kim, who worked with Zena Cardman on operating the robotic arm to grapple onto Cygnus about an hour and 47 minutes ago, the station commander, Sergei Ryzhikov of Roscosmos, and his cosmonaut colleague, Alexei Zubritsky. On the far right is Kimiya Yui of the Japan Aerospace Exploration Agency. And in the front row, NASA's Mike Fink and Zena Cardman. Once again, the robotics officer here in Mission Control is working through a series of carefully choreographed procedures in which commands are sent to the Canadarm2 to maneuver Cygnus to a precise position so it can be aligned to the berthing port of the Unity module on the Earth-facing side of the station. The current estimate is that Cygnus will be within 2 feet of the common berthing mechanism about 35 minutes from now. Once again, this is a very, very slow process, but one that is deliberately crafted so that the vehicle, because it has to be maneuvered into position, does not automatically dock, such as a Progress or a SpaceX Dragon cargo craft. This vehicle, the Northrop Grumman Cygnus XL, as was its predecessor, the original Cygnus cargo craft, and the upcoming Japan Aerospace Exploration Agency HTV-X1 cargo craft that is scheduled to launch from the Tanegashima Space Center in southern Japan on the night of October 20th U.S. time, October 21st Japan time. Those vehicles have to be captured, as was Cygnus this morning, and then maneuvered into place for mechanical installation into these common berthing mechanism ports. Once the Cygnus is precisely aligned into the capture envelope, as it is called, 4 capture latches will pull the Cygnus basically into position, allowing 16 powered bolts to be commanded to complete the rigidization of the structural joint, sealing the interface between the passive and active portions of this common berthing mechanism on either side of the berthing interface. The powered bolts are driven into position and torqued by the closed-loop speed control systems of the common berthing mechanism. There are bolt controllers and bolt actuators that firmly torque these bolts into place, very much like a power tool would screw in screws to a structure. And Cygnus will be permanently attached for the duration of its 6 months on the International Space Station. There will be 2 call-outs from the OSO, the Operations and Support Officer here in Mission Control, basically the Mechanical Systems Officer. First stage capture, that's basically the preliminary capture point for Cygnus on the common berthing mechanism, followed by second stage capture, and at that point we can declare that Cygnus is firmly attached to the space station for the start of leak checks and the opening of its hatch by the Expedition 73 crew later today. Cygnus was launched from the Cape Canaveral Space Force Station in Florida off of Pad 40 on Sunday evening at 6:11 p.m. Eastern Time atop a SpaceX Falcon 9 rocket. The Falcon 9 delivered the Cygnus with spacecraft separation occurring about 14 minutes and 45 seconds after its launch. Cygnus began a stair-step approach to elevating itself through a series of rendezvous burns to match the altitude of the station. Everything went by the book until very early Tuesday morning, when the software limits that were conservatively calculated for the Cygnus burn plan prematurely shut down a pair of engine firings before their completion, leaving Cygnus in a trajectory that would not have been compatible with a rendezvous to the International Space Station. Northrop Grumman engineers sharpened their pencils, went back to the drawing board, consulted with NASA engineers as well, and devised a revised burn plan that phased Cygnus to a point about 500 kilometers behind the International Space Station, where the revised burns began to be executed under adjustments to the software itself. All of the burns on Wednesday night and all through the early morning hours this morning, however, were perfect. Everything was flawless in the final phases of the rendezvous that brought Cygnus to the station for its grapple by the Canadarm2 robotic arm at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time, as the two vehicles flew over Central Africa. We have a short loss of signal from the International Space Station while we pass in between satellites on our tracking and data relay satellite system. Once again, Cygnus is gently, carefully, methodically being maneuvered into an installation position to align its passive common berthing mechanism with the active common berthing mechanism on the Earth-facing port of the Unity module of the International Space Station. These berthing mechanisms are comprised of latches and bolts that essentially torque down and bolt the vehicle into place for its planned 6-month stay on board the station. All quiet here in Mission Control in Houston. The Northrop Grumman engineering team of flight controllers continuing to watch over Cygnus's systems from their vantage point at the Northrop Grumman Mission Control Center in Dulles, Virginia. The two flight control teams working in tandem with one another throughout the course of the overnight hours to guide Cygnus in for its capture almost 2 hours ago. Cygnus is in great shape, receiving power at the moment through the robotic arm itself. Once it is attached and bolted into place on the Unity module of the station, it will receive space station power for the duration of its stay on board. The current plan calls for a late November detachment of this Cygnus cargo craft from Unity, basically reversing course from what we're doing at this hour. where it will be left in an overnight park position for 2 days to allow the Soyuz MS-28 spacecraft to arrive at the station for a berthing at the Rassvet module of the International Space Station on the Earth-facing side of the Russian segment of the station. That will alleviate any undue loads being placed on the cargo craft by the approaching Soyuz craft that will deliver NASA's Chris Williams and Russian cosmonauts Sergei Kudz-Sverchkov and Sergei Mikhaev to the station for the start of their 8-month mission. Once the Soyuz has been docked, that's scheduled for Thanksgiving Day, the Cygnus will be basically doing exactly what it's doing this morning, and that is maneuvered back into position to be reattached to the station for the remainder of its stay on orbit. This view of Cygnus shows the business end of the vehicle. Basically, that is the passive common berthing mechanism. External cameras on the station conducted a survey of that apparatus following its capture to ensure that there would be no foreign object debris or any other untoward situation mechanically. With that end of the Cygnus, that will be the end that is physically attached and bolted into place on the common berthing mechanism on the Unity module. Here in Mission Control, once the installation of Cygnus is complete, we will have a shift handover to the Orbit 2 team. The lead flight director for Cygnus operations is in the middle there at the flight director console. That is Garrett Hain. To his right is spacecraft communicator Aaron Edwards, who has been talking to the station crew throughout the course of this morning's rendezvous operations and again through the installation coming up. And at the bottom of your screen is Flight Director Ronak Dave. He will be taking over as the Orbit 2 Flight Director following Cygnus's installation and its bolting into place. It has been a busy period on board the International Space Station with the arrivals of the Progress 93 cargo ship this past weekend, today's arrival of the Northrop Grumman Cygnus XL, the new version of the Cygnus cargo craft dubbed the SS Willie McCool, named in honor of the late astronaut who tragically lost his life in the Columbia accident on February 1st, 2003. Coming up in just a few weeks from the Tanegashima Launch Complex in southern Japan will be the Japan Aerospace Exploration Agency's launch of its H-3 rocket to carry the new HTV X1 cargo craft into orbit. It will spend 3 days phasing toward the International Space Station. That launch is scheduled for the night of October 20th, 8:58 p.m. Central Time, which will be 10:58 a.m. Japan time on October 21. HTV X1 is scheduled to arrive at the station for its robotic capture and installation on October 24th. HTV X1 will be attached to the Earth-facing port of the Harmony module. Between Progress's arrival the other day and Cygnus's arrival today, a total of more than 8.3 tons of cargo will have been delivered to the station, and adding to that the more recent arrival of the SpaceX 33 Dragon craft, complete with a reboost kit in its trunk to provide reboost capability for the station, saving propellant for the Russian vehicles that are also bear some of the load for reboost and debris avoidance maneuver capability for the international outpost. We will be reacquiring our downlink video capability from the station momentarily on the tracking and data relay satellite system. The station with Cygnus firmly in tow.
Station on 2 with a question on my upcoming Earthshine activity.
Go ahead on 2.
Just want to make sure that you all are okay with me opening up the cupola shutters in order to complete this activity.
Checking. All right, Johnny, your go to open those shutters for your activity.
Thank you very much.
Johnny Kim aboard the station, acknowledging Aaron Edwards, the spacecraft communicator here in Mission Control, just checking to make sure that the shutters on the cupola can be reopened now that activities have shifted from robotics that he and Zena Cardman were involved in earlier today to the installation, which is under the control of the robotics officer here in Mission Control, the Robo, as is his call sign. The station and Cygnus are currently flying 260 miles over southeastern China, about to begin a northwest to southeasterly track to carry it across the Pacific Ocean. We are about 32 minutes until we move into an orbital sunrise. And again, the slow, methodical maneuvering of Cygnus to its alignment position, where its berthing mechanism will be precisely aligned with the common berthing mechanism that will capture it basically on the Earth-facing side of the Unity module of the International Space Station, to enable 16 bolts to be driven mechanically to firmly latch Cygnus to the station for the remainder of its stay on orbit. This is Mission Control Houston. It has been about 2 hours and 12 minutes since the Cygnus XL, the Northrop Grumman cargo ship, was captured by the space station's robotic arm under the control of Johnny Kim and Zena Cardman, who worked those procedures from the cupola workstation on the International Space Station. At this hour, Cygnus is hovering over the common berthing mechanism on the Earth-facing side of the Unity module, being aligned for its ultimate installation into what is called a capture envelope to enable a series of latches first to pull Cygnus in for the beginning of the bolting of Cygnus into place by 16 bolts, 4 gangs of 4 bolts apiece. This view is from a camera in what is called the centerline camera berthing system. This is a visual alignment tool that is used to ensure the precise alignment of the Cygnus's berthing mechanism with the common berthing mechanism on the Earth-facing side of the Unity module. The robotics officer here in Mission Control reports that he has one more maneuver that will take about 4 minutes to complete, that will place Cygnus within 2 feet of the Unity to begin a more precise alignment before it enters its capture envelope. This is Mission Control Houston. Just to recap, you're looking at the Northrop Grumman Cygnus XL cargo craft, which executed a flawless rendezvous this morning to arrive at the International Space Station, where it was grappled 2 hours and 16 minutes ago at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time, to complete a 4-day journey following its launch Sunday evening from the Cape Canaveral Space Force Station in Florida atop a SpaceX Falcon 9 rocket. Loaded with more than 5 tons of cargo for the Expedition 73 crew, Cygnus is in the home stretch before its berthing and bolting into place on the Earth-facing side of the Unity module of the International Space Station. Cygnus, which is at the end of the station's robotic arm and the International Space Station, flying 260 miles over the western Pacific Ocean, moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator. All of Cygnus's systems operated flawlessly throughout the course of its rendezvous in the overnight hours. It wound up right where it was supposed to be, following a revised burn plan that was devised by Northrop Grumman in the wake of two abbreviated shutdowns of main engine firings in the early stages of the rendezvous sequence, attributed to overly conservative software limits that had been established pre-flight. Those software limits were adjusted, a new burn plan was executed, and done so in flawless fashion to bring Cygnus to its eventual home at the end of the robotic arm, and where it will be bolted into place on the Unity module a short time from now. Once we get to the actual installation of Cygnus, you'll be hearing call-outs for first stage capture and second stage capture. These are two phases of the installation process for a vehicle that is being mechanically bolted into place on these common berthing mechanisms. The bolting itself is conducted in several stages. The first stage acquires all 16 bolts and their mating nuts and torques them into an acquired bolt preload of some 1,500 pounds that is measured by strain gauges within the bolts and monitored by the operations and support officer, the mechanical systems officer here in Mission Control. After this initial torque is complete, further torquing is discontinued so that temperatures between the passive ring and the active ring, essentially both sides of the berthing interface between Cygnus and Unity, can be equalized. The bolts are ultimately commanded in groups of 4. There are 4 gangs of 4 bolts apiece, 16 in all, to a final load of over 19,000 pounds per bolt, ensuring a rigid and permanent structural mating of the cargo craft to the International Space Station. Again, a view from external cameras on the International Space Station showing the Cygnus cargo craft slowly but surely being aligned with that circular mechanism. That's the common berthing mechanism on the Earth-facing side of Unity. We're just a few minutes away from what is called the pre-install position, where Cygnus would be 2 feet away from the common berthing mechanism on Unity. Once it moves into that capture envelope, we'll be hearing calls for RTLs, that's ready to latch indications from the mechanism itself, the common berthing mechanism. On the station side, it's called the active common berthing mechanism. The passive side is on the Cygnus side. The chatter here in the flight control room centers around Cygnus being moments away from being in the pre-install position.
Go ahead, Mike. We're with you on 2.
Yes, good morning. We are finished with the velocicalc measurements, and the next step would be to remove the Node 1 diffuser covers.
All right, Mike, we have a couple safing actions we need to take from here, so I'll get you to stand by for 2 minutes. I'll get back to you.
No hurries. I'm still putting away the velocicalc meters, so take your time. Just let me know when you're ready.
We will do, and while I have you, Mike, I copy your your crew note there about the temp stow, the battery. We're happy with that. We'll keep watching that for the next day.
Okay, I'll hold on to the battery, and then you'll let us know via daily summary or something that we should discard it or keep it. Thank you.
The Cygnus cargo craft, loaded with more than 5 tons of supplies for the Expedition 73 crew, is almost at its parking place on the Unity module of the International Space Station. Everything has gone very smoothly all through the morning. A textbook rendezvous that resulted in its grapple by the Canadarm2 robotic arm at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time. The robotics officer here in Mission Control has maneuvered Cygnus to what momentarily will be called the pre-install position for a final alignment before it is guided into the RTL, or ready to latch configuration, where it latches in the common berthing mechanism on Unity, that circular device that you see almost right at the interface with Cygnus, will begin to draw Cygnus in flush, so that both sides of the berthing interface are flush against one another, enabling the start of the bolting of 16 bolts, 4 gangs of 4 bolts apiece, to mechanically attach Cygnus to Unity.
At this time. Thanks.
The International Space Station and Cygnus flying 260 miles over the Pacific Ocean, passing over Samoa, the Cook Islands, and Tonga, moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator, as we are in the home stretch of Cygnus's arrival at the complex. With the space station now in what is called momentum management, essentially ensuring that there are no untoward maneuvers that are planned for the space station during the final stages of this delicate installation operation. The robotics officer is estimating that we're about 15 minutes away from being at the RTL, or ready to latch position, which will set the stage for first and second stage capture of Cygnus, which amounts to the initial two phases of the bolting and bolt loading process that will physically attach the spacecraft to the international outpost. As mentioned earlier, we will be reversing this process and detaching Cygnus from Unity in the November 25th timeframe, a couple of days before the Soyuz MS-28 spacecraft launches from the Baikonur Cosmodrome. That's scheduled for Thanksgiving Day, with NASA's Chris Williams and Russian cosmonauts Sergei Kudz-Sverchkov and Sergei Mikhayev on board to begin their 8-month mission on the complex. That is scheduled to be a two-orbit rendezvous. That vehicle is going to be docked to the Rassvet module on the same Earth-facing side of the station as is Cygnus. The goal in mind here is to prevent any inadvertent loading onto Cygnus by the arrival of the Soyuz spacecraft. So it will be detached by the robotic arm and moved into what is called an overnight park position to allow Soyuz to dock. Following the docking of Soyuz, then Cygnus will be reattached to the Unity module, just as you're seeing in this view from external cameras on the station. So this is the first of several acts of attachment, detachment, and reattachment for the Cygnus spacecraft during the course of its 6 months at the International Space Station.
Station on 2 for Moonshine.
Go ahead, Johnny. We're with you on 2.
I'll get a couple more eyeballs to back me up, but I'm looking outside windows 1, 2, and 6, and I cannot find the moon. I should be able to see it now, and I'm wondering if it's behind the arrays.
All right, we're checking, Johnny.
Cygnus now being maneuvered into what shortly will be the ready-to-latch position. It's been just over 2.5 hours since its capture. Johnny Kim and Zena Cardman were operating the station's robotic arm.
The array was blocking, and now we have a good visual of the moon.
You found the moon. Fantastic.
Cygnus was grappled at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time, as Cygnus and the station flew 260 miles over Central Africa. And the robotics officer reports that the Canadarm2 that is in the grasp of Cygnus is pushing in for ready-to-latch indications. And we now have 4 ready-to-latch indications. This is the precursor to the start of the bolting of Cygnus into place. There are 16 bolts in all that are torqued into place in 2 stages so that we have a hard mate between Cygnus and the Unity module to which it will reside for the next 6 months. A view of the flight control room here at Mission Control in Houston as the shift handover is just beginning, as we are just a few minutes away from the final bolting into place of Cygnus to the Unity module, following a flawless rendezvous this morning and a robotic capture of Cygnus that occurred 2 hours and 41 minutes ago. And the robotics officer is about to place the arm into what is called limp mode, essentially disabling it from any further motion to provide a quiescent state for the start of the bolt loading. With the arm now in limp mode, first stage capture is complete. Standing by for confirmation of second stage capture. We're in a brief handover between satellites on the tracking and data relay satellite system. We are in the process of standing by for confirmation of second stage capture and the bolting of Cygnus into place. Still awaiting confirmation of second stage capture. We should be getting that momentarily.
Houston station for node 1 diffuser covers.
We're with you on 2.
Right, the diffuser covers are removed and we are ready for IMD activation. And just as a cool thing, sounds like we're hearing some common berthing mechanism IMCA motors turning. So good luck.
Roger, we copy the covers, and yes, I think we're making good progress with the mate.
Good, Cygnus. I think progress was a week ago. Ha ha ha.
Aboard the station, NASA astronaut Mike Fink relaying that he can hear the bolting of Cygnus into place. We're standing by for confirmation of second stage capture that essentially will be the hard mate of Cygnus to the Unity module. This is Mission Control Houston. The Mechanical Systems Officer here in Mission Control reports that Cygnus has been mechanically attached. We do have a hard mate now with second stage capture. That coming at 9:10 a.m. Central Time, 10:10 a.m. Eastern Time, as the International Space Station and Cygnus flew just off the coast of Chile. So with that, Cygnus's arrival at the station is now complete. There are 3 cargo ships now at the station, the SS Willie McCool, the Roscosmos Progress 93, and the SpaceX Dragon cargo craft. All of that food, fuel, and supplies having been delivered to the International Space Station. This will kick off several hours of leak checks at the Cygnus Unity docking or berthing interface before the crew presses into hatch opening and the beginning of the unloading of cargo later today. Once again, Cygnus now hard-mated, firmly attached to the station at 9:10 a.m. Central Time, 10:10 a.m. Eastern Time, not quite 3 hours after its robotic capture, following a flawless approach, rendezvous, and terminal phase of its approach to the station. Everything went by the book throughout the course of the morning. With that, we will wrap up our coverage of Cygnus's arrival at the International Space Station. Cygnus, now firmly attached to the station, will receive station power shortly, and its hatch will be opened later today. So with that, we wish you a good day on this Thursday. We'll be signing off for now. This is Mission Control Houston.